Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video, Integration by Parts, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will discuss integration by parts for both indefinite and definite integrals. Integration by parts is based on the product rule for derivatives. Remember, the product rule states that for any two continuous functions f and g, the derivative of two functions that are multiplied times each other is equal to the first function times the derivative of the second, plus the derivative of the first times the second function. If we take this as an equation and integrate both sides, we get f of x times g of x equals the integral of f of x times g prime of x dx plus the integral of f prime of x times g of x dx. We can then solve for the integral of f of x times g prime of x dx, which is equal to f of x times g of x minus the integral of f prime of x times g of x dx. We can also derive a shorthand version of this by setting u equal f of x and v equal to g of x. Du will then be f prime of x dx, and dv will equal g prime of x dx. When we replace the values, we get the integral of u dv equals u times v minus the integral of v du. As an example, let's use integration by parts to solve the indefinite integral x e to the x dx. It is important to choose a u and a dv such that the integral of v du will be no more difficult to solve. Therefore, we let u equal x, making du equal dx. Then dv equals e to the x dx. V will then be e to the x. Remember our equation, the integral of u dv equals u times v minus the integral of v du. Inserting our values, we get the integral of x e to the x dx equals x e to the x minus the integral of e to the x dx. Here, taking the integral is much easier. We arrive at our final answer, x e to the x minus e to the x plus c. In another example, let's solve the indefinite integral x cosine x dx. This time we let u equal x, which makes du equal dx. dv will then be cosine x dx, making v equal to sine x. We start with our equation, the integral of u dv equals u times v minus the integral of v du. Therefore, the integral of x cosine x dx equals x sine x minus the integral of sine x dx. When we solve the final integral, we get our final answer, x sine x plus cosine x plus c. Integration by parts may also be used to find definite integrals. In this case, the integral from a to b of u dv equals u times v evaluated from a to b minus the integral from a to b of v du. As an example, let's solve the following definite integral from 0 to pi of e to the x cosine x dx. Here we let u equal e to the x, making du equal e to the x dx. Then dv equals cosine x dx, and v equals sine x. By filling in our equation, we get the integral from 0 to pi of e to the x cosine x dx equals e to the x sine x, evaluated from 0 to pi, minus the integral from 0 to pi of e to the x sine x dx. The evaluation of the first part of this arrives at e to the pi times 0 minus e to the 0 times 0. This term is 0 and can be dropped, leaving the integral from 0 to pi of e to the x cosine x dx equals negative the integral from 0 to pi of e to the x sine x dx. We now apply integration by parts to the new right half of the equation by letting u equal e to the x, du equals e to the x dx. dv equals sine x dx, and v equals negative cosine x. Evaluating that integral by parts gives us minus the quantity of negative e to the x cosine x evaluated from 0 to pi, minus the integral from 0 to pi of negative e to the x cosine x dx. Evaluating the first half, we get minus the quantity of negative e to the pi times negative 1 minus negative e to the 0 times 1 plus the integral from 0 to pi of e to the x cosine x dx. When we simplify, we get the original integral equal to negative e to the pi minus 1 minus the same original integral. We can now add that integral to both sides, giving us 2 times the integral from 0 to pi e to the x cosine x dx equals negative e to the pi minus 1. We divide the 2 to get our original integral equal to negative e to the pi minus 1 over 2. As another example, let's find the integral from 1 to 9 of the natural log of the square root of x. First, we understand that the natural log of the square root of x can be expressed as the natural log of x to the 1/2 power, which is equal to 1/2 the natural log of x. The 1/2 can then be moved outside the integral as a constant. For the remainder of the integral, we apply integration by parts and let u equal the natural log of x. Du is then 1 over x dx. dv equals dx, making v equal to x. When we apply our equation with the new values, we get 1/2 times the quantity of x natural log of x evaluated from 1 to 9, minus the integral from 1 to 9 of x times 1 over x dx. This gives us 1/2 the quantity of 9 natural log of 9 minus 1 natural log of 1, minus the simplified integral from 1 to 9 dx. The natural log of 1 is 0, so that term can be removed, leaving us 1/2 times the quantity of 9 natural log of 9 minus the integral from 1 to 9 dx. When we take the integral, we get 1/2 the quantity of 9 natural log of 9 minus x evaluated from 1 to 9, or 1/2 the quantity of 9 natural log of 9 minus 8. We then distribute to get our final answer, 9 over 2 times the natural log of 9 minus 4. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you and good luck with your studies.